In this video, I will tell you about the process for calculating risk-adjusted optimum portfolio returns using the solver feature in Microsoft Excel. So to begin with, I have downloaded the data of these three stocks, monthly returns. I have calculated from 1st of August 2019 to 1st July 2024. Then by selecting the entire data range for HDFC, I have named it with the name of the stock code HDFC. Similarly, I have done for HUL, as you can see, Hindustan Unilever, and similarly for the third stock, ICICI. So naming the data range with the stock code will help us easily calculate the variance mean using the indirect feature. So to begin with, let's start with the covariance matrix. So here we will use the formula covariance sample, and we will use the feature I just told you, indirect H1, and then we will log this row. And then the column HDFC. So we will also log this column. So we get this value. Now we will copy and paste this as a formula for other cells. Now in the next step, we will be calculating the monthly returns using the option average, again indirect, and then so these are the monthly returns for the HDFC stock. We will copy this formula for the other two stocks, Hindustan Unilever and ICICI. Now in the next step, you can see that we have divided the entire portfolio into three equal parts, making it 100%. Now, as you can see, these are the returns for the individual stocks. Now we need to calculate the returns of the entire portfolio. So we'll be using the matrix multiplication feature. So first of all, I will enter transpose for these weights multiplied by the monthly returns. Always remember that for getting the output results of MMULT, you need to press Control Shift Enter. So we got these return of 1.0309%. Now, similarly, we will calculate the variance of this entire portfolio. So again, we will be using the MMULT, which is the matrix multiplication feature. transpose we will multiply this entire covariance matrix with the weights. So now you can see, as I told you earlier also, for getting the output of the MMULT feature, you don't need to press enter directly. You need to press Control Shift Enter. So you can see that we have got this value. Now, in order to calculate the standard deviation, we will simply multiply variance and calculate its square root, which is the formula. Sorry. Now it's done. Okay. Now we will convert these values, return and standard deviation, into the annualized form. So we will multiply these monthly return with 12 and standard deviation multiplied by square root of 12 number of months. So now you can see that we have assumed that the risk-free rate is 4% here, and we'll also calculate the Sharpe ratio. So Sharpe ratio is the ratio which is signifying that if there is a higher Sharpe ratio of any portfolio, higher the investment performance of that particular portfolio. And the formula is like this: portfolio returns minus risk-free return divided by standard deviation. Now we have got all these values. You can see this portfolio has generated annualized returns of 12.37% with risk of 19.5%. Standard deviation reflects the risk here. The proxy for risk is standard deviation. Returns are mentioned here, 12.37%. So now we want to see that whether this portfolio has generated optimum returns or not. So we will use the solver feature now in the data tab. Case 1, create a portfolio with maximum returns. So I will, under the data tab, I will click solver, and you can see here that there is an option of setting objective. So I will select the objective because here the Excel sheet is telling me that the portfolio returns are 12.37%. So I select this cell and I want to maximize. I want to see that in which scenario, in which case, this portfolio will give me maximum returns. So obviously by changing the variables, right now I have equally divided the portfolio in these three stocks, but now I'm giving the authority to the solver that please change these variable cells in order to generate the optimal maximum returns subject to the constraint. Now, what is the constraint? Constraint number one here is that the entire portfolio will be equal to 1. You may add more restraints, but we will be understanding the case 1 with one constraint. So after inputting this data, you can see that I have already copied this original results solution here, because when I will click on this solve, it will give the results in these tabs itself. So let's click on solve. So you will get the message solver results that solver found a solution. So all constraints and optimality conditions are satisfied. So you can see here, the solver has automatically diverted the entire funds to ICICI. So HDFC, HUL 0% each, and ICICI has been given a portfolio allocation of 100%, and it has generated the maximum highest returns of 22.5%. 41%, although with higher risk, 31% risk. But since we did not keep any constraint on keeping the risk tolerance, so it has given us the optimal return. So you can copy paste this, or we can write this here. In case 1, return 22.4% and standard deviation 31.35%. So I am going back to the original results. Standard deviation was around 31.5%. So I have mentioned the results. I have written the results here. Now let's create case 2 where I want to create a portfolio with minimum risk. I am not concerned with the return. I am a conservative person, for example, so I don't want any kind of volatility. So I will go to solver and I will select this time this tab of standard deviation and click minimize. I want to minimize return. Right now it is 19.5%. Changing variable again will be the same because I want solver to realign the portfolio. And constraint is obviously I have kept the same constraint that the total portfolio value should be equal to 1. So let's click on solve here. So again, solver found a solution. Now let's see the solution. So you can see that this time solver has divided 27% of the portfolio allocation to HDFC, 61% to Hindustan Unilever, and only 13% to ICICI because it was the most volatile. Now you will find that the annualized returns are 9% approximately and standard deviation of 16.88%. So I will write here 9% return and 17% standard deviation. So you can see now with the help of solver has given you an analysis of these two situations. Similarly, you may modify your constraints, other conditions to find out the solutions. But definitely, this is a wonderful feature with which you can not only guide others or students, you may use this technique for rebalancing your own portfolio and also use these features for high quality research for the benefit of the learners participants. I have shared this template, Excel template in the description box, so you may download from there. So thank you very much for listening. Thanks a lot.